I'm Brian. Together, me and my group mates, Crystal and Zenrom, I'm going to discuss more on artificial gravity.
From what we conclude on our research topic, we discovered a lot of new discovery, benefits and development of artificial gravity.
As far as science has progressed, artificial gravity so far is a fiction, and we are currently moving towards it becoming a reality with all the research and development that has been done on it. Other than that, in this video alone, we will be summarizing what has been done and what will be done, what should be done, and what eventually might be done with artificial gravity. The rest about the short experiment we'll be conducting will be done by Brian, who's in the next video.
Of course, there's an equation for this force, and that equation is mass times velocity squared divided by radius. As you can see, you can manipulate this equation by maybe increasing or decreasing the variables. For example, you can see that by increasing the mass or the velocity, it could generate greater centripetal force. And if you increase the radius of the uniform spherical motion, it will decrease the centripetal force. In order to generate greater centripetal force, the objects need to be moving at high speed, but keep in mind that the object needs to have a high mass, and that's difficult. Maybe that's one of the problems why we can't harness the full potential of this artificial gravity. But let me introduce you to something new. Let me help you imagine this concept. Imagine yourself driving a car in a roundabout. It will always feel that you're being pushed away from the center of the roundabout, right? You're being pushed away towards the door. This force that's acting on you is fictitious force, the centrifugal force. But keep in mind that this is on Earth, where there's gravity, and the gravity on Earth is 9.8 meters per second square, and that's high. Well, imagine this, the fictitious force on space, where the mass is big enough, the magnitude is big enough, the velocity of the object is big enough, that it generates high fictitious force that will act as an artificial gravity on its own. Well, this, my friend, is the concept of artificial gravity.
So we are going to perform an experiment to indicate how does artificial gravity works. We just need a string and a ball. So, but for time being, I'm using this earphone. The string of the earphone is a string, okay, basically, and head earbud of the phone acts as the ball. So when we try to spin the earbud, the tension of the string actually creates a force that actually similar to the gravitational force, which is in real life is the gravitational force of Earth, and the earbud actually experience the centrifugal force. As you can see just now, when it spin like vertical up 90 degrees, the earbud doesn't fall towards the center of the Earth. It's because the earbud is experiencing centrifugal force, which is also why the concept of artificial gravity works.
And now we will continue on with the experiment that Brian will be doing.
You can see here that the radius of the uniform spherical motion I will be making is this long, and the mass of the water bottle is affected by this water inside it. So now let's perform the first try.
Now this is trial 2.
Second trial, where I'll reduce the radius by this long. Let's see how it affects the water bubble. You can see that the force exerted on the water bubble is more as the radius is less. This is because the general formula for it, which is centripetal force, equals to mass times velocity squared divided by the radius. When you decrease the radius, it will increase the force. And now I'll be throwing off the water.
And now we continue on with trial 3.
As you can see, I'll be using the radius that I'll previously be using on trial 1, this one. But now there's no water inside the water bottle, so the mass is decreased. Let's see how it affects the force. As you can see, the water bottle is spinning like less push on the outside. That means that the centripetal force is less. As the mass is decreased, this is due to the fact that the equation itself is centripetal force equals to mass times velocity squared divided by radius. So by decreasing the mass, you will decrease the overall centripetal force.
Brian will now show how we do the calculations.
So this is how the calculation is done theoretically, not like you don't submit any numbers to it. So let's see. In trial 2, where I decrease the radius, as you can see here, when I decrease the radius, this will have an effect on the centripetal force, which will increase as you see this division. So by dividing by a smaller number, you will get an answer to be a bigger number. Now let's move on to trial 3, where I decrease the mass. When I decrease the mass, it will have an effect on the centripetal force, which will also decrease the centripetal force. As this is the main multiplication in this right side of mine, and this will have an decreasing effect on the centripetal force. Thanks.
Hello, I'm Jeff Williams on board the International Space Station, Expedition 22, and today I would like to talk to you about centripetal force. A big word, but I know you use it and take advantage of it every day. We've heard about acceleration, linear acceleration and angular acceleration. With angular acceleration, there's a force that's produced. A force, of course, is required to produce an acceleration. That's true in a linear acceleration and an angular acceleration. If, let's say we were to take this object here. This is a tool. It's a special tool that we use on board the space station, actually during spacewalks. But it's a heavy metal object, and that's what I really wanted to use. And you can see I have it tied to a string, or with a string, onto this bungee right here. And it's just floating here in weightlessness. And you can see the string here is rather loose, and it's just kind of floating randomly. If I were to rotate this thing on the string around this bungee, and let me do this, you can see that the string pulls taut and stays tight, and the tool continues to rotate around the bungee. In fact, if you look really close at the bungee, you can see that the bungee bends at the point that it's rotating, and it bends toward the tool. And that is caused by the centripetal force due to the angular acceleration of the tool as it rotates around, keeping this string tight and keeping the rotation in a circular motion. It's the same kind of force that applies to the rotation of planets around the sun, or the moon around the Earth, or the space station around the Earth. Well, here in space and weightlessness, I have this bag of tea, and you can see it has bubbles in it, but they don't rise to the top. In fact, I'll shake them up here, and you can see the bubbles spread out throughout the tea. Of course, we're in weightlessness. We have the absence of gravity, and we know that bubbles rise for what reason? In the presence of gravity, the air is lighter than the liquid, so the air floats to the top. Gravity causes the liquid to go down, and that actually pushes the bubbles up. There's the bubbles spread throughout the tea, and if I rotate it, the bubbles coalesce to the center of the tea and eventually form a circle. Why do they do that? Because of the centripetal force spread throughout the tea. The liquid tea goes to the outside of the bags, and it forces the air into the center, because the air has less mass, less density than the liquid. So the air goes to the center I'll try it one more time. See the air coalesce to the center, form a circle. Due to the centripetal force applied in this, because it's turning, it's rotating, the liquid goes to the ends and the air ends up in the center of the liquid. Okay, that's enough. I'm going to just pull away from there. And what happened? There we go. And I'm going to take my piece of dental floss. And I'm going to just use the dental floss to kind of guide the water bubble. So let's see here. What I'm going to do is I want to try to rotate the water bubble. And we'll see what happens. Actually, I'm going to turn like this. I'm going to try to rotate the water bubble this way. Because if I give you this angle, you'll be able to see it change shape. Actually break into several parts. And you can see they're no longer cylinders. This one's rotating like this. And that's due to the centripetal force within the water bubble.
So there will be multiple real-life applications for artificial gravity when it becomes a reality. And so far from what we understand, as said by Stephen Hawking himself, who is a genius, life out of Earth is a very real possibility and something that we humans should strive to achieve, because as now, the world is actually dying in a sense with the overpopulation of humans and the decrease in environment, as well as the overuse of a lot of toxic chemicals in the age of development for a better future of the human race. We feel that artificial gravity would be a bridge off to a better world, as being able to apply the knowledge of artificial gravity into the space, which is so huge, and it would allow us to push a lot of industrialization that is harming the Earth out into space, where there is no worry of radioactive harm to places, waste of land, explosions, environmental pollution, and a lot of other things. So we think the real life applications of artificial gravity vary, and is actually really up to the imagination of the human mind. But as of now, the importance of having artificial gravity would be to create a spaceship that allows astronauts and a lot of people to eventually go on space traveling and find places that no one has ever been, or discover new things that could help us in our development of the human technologies. Other than that, the real life applications other than space travel and reducing the impact of no gravity on astronauts who go out into space for extended periods of time, who come back with backaches, and then a lot of other unknown health medical issues, like their calcium comes out of their bones due to the fact there's no gravity suppressing it into their skeleton, and dealing with various other illnesses where they lack of use of muscles and as such.
So thank you guys for watching our video. I hope you guys found this video useful, and I hope this would broaden your imagination, and would one day in the future would be the future development of artificial gravity. Thanks.